What's up, my chemistry students? It's Mrs. Thompson here, and today we're working on calculating pH. Take out your scientific calculator. We're going to use it today, just for a little bit. All right, first, before we talk about pH, I want to talk about the autoionization of water. Auto just means self, so it's the self-ionization of water. All right, so first, the self-ionization of water is a reversible reaction. Water will break up into hydrogen ions and hydroxide ions. That's why we call it HOH sometimes, because it splits up into H plus and OH minus. Now what happens to that H plus is it actually will move on and find another water molecule and attach itself to that water molecule and form a hydronium ion. Okay? And so what really happens is this second drawing here. What you get is a water molecule, actually two water molecules, forming hydronium ions and hydroxide ions. One of them acts as the Bronsted-Lowry acid. Why? Because remember, it's the acid that is donating the hydrogen ion. So let's say it's this hydrogen that gets donated to the base. Say it goes there. And that's the Bronsted-Lowry base because it accepts the hydrogen. Okay, so you have an acid-base reaction that's actually happening within two water molecules. And that's happening constantly in water. Water is always self-ionizing. And so we have this equilibrium that's occurring. This equilibrium of water breaking up into hydrogen and forming hydroxide, and then the hydrogen attaching itself to water and forming hydronium ions. Well, we can write an equilibrium expression because this is a reversible reaction. And so we would do this by stating that the concentration of hydrogen ion times the hydroxide ion would be equal to KQ. Well, we can also measure this. And at 25 degrees Celsius, this has a value of 1 times 10 to the negative 14. Now remember this number because it's going to come back when we talk about calculating pH. All right. So that H plus times OH is 1.0 times 10 to the negative 14. All right, so what is pH? We've used the pH scale. We've measured in pH. What is it? It's actually the power of the hydrogen. It's a French word. It's like pouvoir of hydrogène. It's the power of the hydrogen. How much hydrogen is there? And it's a logarithmic scale. And it ranges from 0 to 14. 7 is right in the middle. Now, 7 is actually neutral, and below 7 we call it that acidic. And it's acidic for one reason. It's acidic because there are more hydrogen ions in the solution than there are hydroxide ions. To the right of 7 we have things that are basic, and it's basic because there are more OH minus ions in the solution. Okay. It looks, well, actually, here's this. H plus ions and hydroxide ions are actually equal at 7. So when the pH is 7, the amount of OH minus and H pluses are equal. I'll come back to that. All right. At 0, it has way more H plus ions than it has hydroxide ions. One thing I want you to note is that I will use H plus ions and hydronium ions, and I want you to think of them as the same thing. Because remember, these go on to attach to water molecules to form hydronium. Okay. All right. So at a pH of 7, the concentration of H plus and OH minus ions are equal. That's why we say we have something that's neutral, because all the H pluses cancel out the OH minuses. When it's acidic, we have lots of H pluses. So the power of the hydrogen ion is great. When we have a pH of 14, the power of the hydrogen ion is not so great. It's actually got lots of hydroxide ions. And so in between times, well, we have a different ratio of hydrogen ions to hydroxide ions. It's not like they disappear. It's just that we have a greater concentration of one or the other. Alright, so this is a chart, and this is going to help us with our pH calculations. So you have to draw this chart. Alright, this chart shows us the relationship between each one of the ions. And so we're going to go through pH to H+. This is concentration, because we're talking about brackets. We're also going to go from POH to OH-. And then we're going to relate these two together and these two together. Alright, when you think of P, or power, think negative log. Now what's negative log? It's a function in your calculator. So you maybe talked about this in math. If not, it's okay. We just need to use the calculator part of this. We're just doing that to the base 10, so if you have used it, great. Today, we're going to just use it a little bit. Okay. So here we go. I'm going to do some examples, and we're going to go through this chart. Okay, so it says calculate the pH of H+. It's 1.0 times 10 to the negative 5. All right, so it says calculate pH. So we want to find this if H+ equals this. So that means we're going from here to here. Okay. So we need an equation that has these two items in it. So if I look, this one has both of those in it, and so does this one. There are two equations that have just H+ and pH in it. Well, which one do we use? We're going to use the one that solves for the thing that I'm trying to find. I want to find pH. So I want the one that says pH equals. Well, that's the top equation. pH equals the negative log of H+. Okay. So pH equals the negative log of H+. That's my equation. We're going to plug in the concentration. It's 1.0 times 10 to the negative 5. So pH is the negative log of 1.0 times 10 to the negative 5. That's how we're going to plug that into our calculator. pH. Well, we don't plug in pH. We just write negative log. My log button is, let's see, right there. Negative log of 1.0. I'm going to use the second button and the E. Negative 5. So I know this is going to be ridiculously hard to see. There it is. If you can't see it, ask me later. I'll show you. Okay, and then I hit enter, and look, I get a nice little number. It's 5. pH is 5. I'm going to give myself 2 sig figs because guess what? The number in front has 2 sig figs. Well, the nice thing about logs, when the coefficient is 1, okay, and this is only if the coefficient is 1. If the coefficient is 1, then all you have to do is look at the exponent. So here's my coefficient. It's 1.0, which is just 1. I can look at this. It's a 5. So pH is 5. Be very careful. If this changes, this is no longer true. So because this is a 1, or it could even just not be there, because I could just say negative log of 10 to the minus 5, and that would just still be 5. Okay. All right. So today, we will not be using this. We'll use it next time. All right. But tomorrow or in class, I'm going to need to show you how to use this with logs. All right. So that's my final answer. 2 sig figs because 1.0 had 2 sig figs. All right, next question says, calculate the pOH if the OH minus is 1.0 times 10 to the negative 7. Okay, so that means that I want pOH, it's right here, and I have OH, which is right here. So that's a one-step problem from here, or here to here. Okay, so the equations that I have to deal with this one-step problem are right here, these two. Which one do I use? Well, which one solves for pOH? This one does, the top one. Okay, so then I'm going to plug that in. pOH is the negative log of the OH. Plug in the 1.0 times 10 to the negative 7. Now this works the same way. Because we're dealing with logs, and I didn't say this, logs are to the base 10. Okay, because I'm dealing with logs, I can and the coefficient is 1, I can simply look at the exponent. So the exponent is -7. This negative is canceled by this negative, and so this would just be 7. For sig's sake, 7.0. Okay, hopefully we're doing all right. All right, calculate the OH minus if the H plus is 1.0 times 10 to the -7. All right, this is a little different. Now we're dealing with OH minus and H plus. If I asked you to find the pH, you might say, okay, well, if the H plus is 1.0 times 10 to the -7, the pH will be 7. Okay, easy. But now I'm asking you to find the OH. So we are right here. We have this. We want that. Still a one-step problem. So we need one equation that deals with that. That's this one right there. 1 or H plus times OH minus is 1 times 10 to the -14. That's right. All right, I'm going to rearrange this to solve for what I need. Well, I want the OH minus. So to get OH minus by itself, I'm going to divide both sides by H plus. Okay, H plus cancels, and so OH minus is going to be this divided by H plus. So I can plug in H plus. Alright, so let's just deal with scientific notation. I don't even need my calculator for this. 1 divided by 1 is still 1. Dividing in scientific notation is subtraction. -14 minus a -7 is -7. So that's 1.0 times 10 to the -7. Okay, you should see something. If I asked you to find the POH, this would be a POH of 7. So the pH is 7. The POH is 7. The OH minus is 1.0 times 10 to the -7. H plus is 1.0 times 10 to the -7. Why? Because it's neutral. Okay, they're equal because it's neutral. All right, number 4. Calculate the pH if the POH is 8. All right, so let's find this on the map. Right here. Right there. And so we need an equation that deals with that. This one does. Notice it has 2 places past the decimal, and you're adding. And so adding involves laces, so be careful with that. All right, so we're going to write down that equation. And then we're going to plug in the 8 or rearrange the equation. So if I want to solve for pH and I have POH, then pH is going to be 14 minus the POH. So 14 minus 8. 14 minus 8 is 6. Notice I do not have any places past the decimal. So there's my pH. That's my final answer. One-step problem. Number 5, calculate the H plus if the pH is 4. Alright, so let's see. Here's H plus, and we have the pH. So one-step problem still. And one equation to deal with that. This one, no, that's solving for pH. We have pH. It's this one. 10, or H plus is 10 to the minus pH. Okay, so then we'll just plug that in. H plus is going to be 10 to the minus 4.0. And if I had to plug that into my calculator, that's just going to tell me, because it's to the base 10, that it's 1.0 times 10 to the -4. And that's my final answer on that one. There it is. Next question. Calculate the H plus if POH is 9. So here we go. We're at H plus here. We want POH. Oh, it's there. Okay, there is no arrow from here to here, which means we have a 2-step problem. You can't do this. You cannot go across. You can only go this way and down, or I can go, we're starting at POH, so I can either go this way and up, or up and then this way. My suggestion to you is that if you have to decide this route, take this route. So if it's whatever chance you get, take this route. It's always easier because it's subtraction. Alright, so then I'm going to go through there. So I'll start here, go up there, and then go over. So that means that the pH plus the POH is 14, or the pH plus 9 is equal to 14. And so then pH is 5. If the pH is 5, and I want to find the H plus, well, then we're going to use that the H plus is equal to 10 to the negative pH, or H plus is 10 to the negative 5, or 1 times 10 to the negative 5. That's my final answer. All right, number 7. Calculate the pH if the OH minus is 1.0 times 10 to the negative 13. So here's OH minus, here's pH. I can't go across, so I can go up and over, or across and up. I suggest you go through here, so I'll go across and then up. So then I'm going to go from OH to POH. So OH to POH, that was this one. So POH is negative log of OH. So POH is negative log of 1.0 times 10 to the negative 3, or 3. And then pH plus POH is equal to 14, or pH plus 3 is equal to 14, and the pH is 11. All right. We will try lots of these in class. See you next time.